Right, here's our video for 5.10a, adding and subtracting radicals. We started with this warm-up, and you'll notice there's no radicals in the warm-up. It's just a thing to review what we mean when we're talking about like terms. So if you notice in this problem, when we're trying to combine similar terms or like terms, x squared matches with x squared, and we don't need to change the exponents when we're adding or subtracting. We only change them when we're multiplying or dividing. And in this case, we have 3x squareds. We're going to add one more x squared. When you don't see the coefficient, it's understood to be 1. So 3 plus 1 is 4. So we have 4x squareds altogether. Same thing for 9x and negative 2x. They're like terms because the variable portions match and the exponents on those variables also match. And we just do math on the 9 and the negative 2, and that makes 7x. And then the last thing is the constants. Negative 5, positive 3 makes negative 2. So for like terms, we match up variables, exponents, but we only do math on the coefficients, the numbers in front. So today we're going to do that same thing with radicals. So this part of the note says, just like we could only combine like terms in the warm-up, when dealing with radical expressions, we can only combine like radicals. Like radicals are radical expressions with the same root, sometimes also called the index, and the same radicand. And the radicand is the stuff inside the radical, right? But it's much faster to say radicand than it is to say stuff inside the radical. So we'll say radicand. So pause for just a minute and ask yourself which of these numbers are the radicand and which of these are the root. So the 56 is the radicand, and the 3 is the root or index. So then this set of examples right here, we don't need to simplify any of the radicals. We're just looking for like radicals, and if they are, then we will do the math on their coefficients. So for this first one, it is true that the radicands match and the roots match. So we can simplify this doing the math only on the coefficients. So 2 minus 7 is negative 5 square roots of 2. Because what you're saying is I have 2 radical 2's and I'm subtracting 7 radical 2's. So I have negative 5 radical 2's altogether. In this next example, the radicands match, the roots match, so we can do math on the coefficients. 5 plus 4 is 9, so I have 9 cube roots of y. In this example, they don't match, right? The roots match, but the radicands don't. So in this case, you can't add, you can leave it like that. You can write NA for not applicable. I'm just going to write here, can't simplify because radicands don't match. All right, then what's changing down here is we have 3 terms, but the principle stays the same. Do the roots all match? Do the radicands all match? And they do, so we're just going to do math on the coefficients. So 2 minus 6 plus 4, that is negative 4 plus 4, which is 0. So we have 0 square roots of 5n. Now, you can leave this answer either like this or simplify by multiplying by the 0 and get 0. Let me tell you what I don't want you to do. I don't want you to write this. Because when there's no number written in front, that's implied to be a 1. And 1 and 0 are not the same. They mean different things. So we are not going to do that. And then for this one right here, again, the radicands all match, the roots match. So we are going to do math on the coefficients. When I don't see a coefficient, so just like I talked about here, when I don't see a coefficient, I know it's 1. So now I have 1 plus 5 minus 4. That is 6 minus 4, which is 2. So I have 2 fourth roots of 3xy. And then for these problems over here, we need to do factor trees to simplify first. So you'll notice the radicands don't match, but after we do factor trees, they will. So for example, I can't do a factor tree on 5, but on 20, 4 times 5, which is 2 times 2. And so I can rewrite that as the square root of 2 times 2 times 5 plus 3 rad 5. And I'm looking for pairs of 2, so I'm going to pull out 1. So that gives me 2 square roots of 5 plus 3 square roots of 5. And then the math on the coefficients gives me 5 radical 5. Now I want you to pause the video and do factor trees on both this 24 and this 375. Rewrite them and then combine the like radicals. So there are my factor trees. I'm going to collect all the numbers that are at the ends of branches. So 24 rewrites as 2 times 2 times 2 times 3. 375 rewrites as 5 times 5 times 5 times 3. Because my root is 3, I'm simplifying in groups of 3. So I can pull out 1, 2 here, and 1, 5 here. So that leaves me 2 cube roots of 3 minus 5 cube roots of 3. Now that their roots and radicands match, I do math on the coefficients. 2 minus 5 is negative 3 cube roots of 3. And one thing I want to add is this. If one of these radicals already had a coefficient out front, you would just take that existing coefficient and multiply by whatever number you pulled out. So like, let's say I had this same thing, but with a 2x out front, right? So same thing, but I put a coefficient. I would simplify this by pulling out 1, 2, and then I would multiply that by that 2x, and I would have 4x cube roots of 3.